Alright, in this video we're going to put the log class into action.
Woohoo, let's do some stuff.
Alright, we're going to turn our attention now to the game class, and we're going to jump down to load content. Alright, inside of load content, we're going to do a few things, and a little bit of preparation to get everything ready for our log. Now, when we set up the log, of course, we need to pass in a rectangle describing the bounds of the log itself.
Okay.
We want this log to always be snapped to the bottom of our game screen, matching the width of our game screen.
All right.
And in order to do this, it would be helpful to know the dimensions of our game screen.
You know, it's funny. For a second there, I was going to ask you why don't put it on top, and then I remembered what the game looks like when you play. I was like, yep, that's why he put it at the bottom.
And once we get into drawing of notes, then it would be inconvenient to not be able to see the note tracks behind our log.
Anyways, continue.
All right, so gathering the current screen resolution. What we're going to do is we're going to use the presentation parameters type, which will allow us to look into the graphics device and ask it what the dimensions of its back buffer is. So we'll drop this down here, presentation.
What the dimensions are.
Yes, well,
just tell me to shut up.
Filtered into the English language, that's how it would be described.
Sorry.
All right, we have a presentation parameters variable. We'll simply call that PP for short. And we'll set that equal to the current graphics device dot presentation parameters.
All right.
The main goal of this local variable is this is a lot of text and pushes us off the screen very quickly. This is a very small variable, makes it very easy to type. All right, moving on. Let's actually jump down here below style. As a matter of fact, it's important that this happen after style because we're going to leverage some of the things that were loaded using style. So jumping down here, actually I'm also going to drop down a comment. As simple as load content is, there are some things we're going to be doing as the game progresses. And so we're going to have several things that are going to happen here. So a simple comment saying log. And a simple comment here saying, I know this is highly redundant at this time, but it'll make it a little bit easier to read later.
Sure.
When we have a lot of stuff going on.
You go take a vacation and come back. You'll be glad you did that.
Alright, so as far as log initialization, one thing that we haven't yet defined is exactly how tall the log should be, because of course based on the screen we know it's going to match the screen width, and its positioning is going to be based on the screen height, but we haven't said how high the log itself is, and we're going to describe that with a very simple local variable called log height.
So this will just be hard-coded to a number?
Yep, be directly hard-coded to the magic number 185.
I love magic numbers.
Now once again, before everyone gets all ready to jump up and down about the use of magic numbers, this is again for development purposes.
Yeah.
And so we're going to leave this right here to keep things simple.
You know, later on, once you got a config system in place for a config file, you could probably define it through your config file.
Right, again, and especially since the config system being designed so you can add information to it whenever you need to.
Right.
And, of course, throughout the development of the game, there may be many things you want to add, and this can simply get pulled along with everything else.
So if magic numbers are freaking you out, do it now, fix it later.
Alrighty, so moving on. Now that we have come up with how high we want our log to be, we can run a call to log.initialize.
Woohoo!
And we're going to feed in, or rather we need to feed in, a font, a texture, and a rectangle. We have a font because now that we've initialized style, we have style.font_small. And again, since we have initialized style, we have access to style.fill_texture. And now our bounds, we need to put the bounds together right here. We'll make a new rectangle, and we need to specify some parameters. We'll specify x as 0, so that means we'll be snapped to the left side of the screen. Y will need to be based on our screen height. So we'll look into that presentation parameters variable and look at back buffer height. Now, of course, we don't want to put it right below the screen. We actually want to jump up a little bit.
So you're going to slide it up by subtracting the log height.
Right, we'll subtract log height from this. And so we'll be on the screen by the amount given in log height.
Makes sense. 185 pixels in this case.
And then the last two things are the width. So we'll simply fill out the screen width, looking into presentation parameters dot back buffer width.
So the log will run the entire width of the screen.
That's right.
And the height will just be log height.
And yes, height will be log height. That finishes off our rectangle, and it also finishes off the call to log.initialize.
Okay.
So we'll terminate that, scroll back to the beginning, and here we are with log.initialize. As a matter of fact, we need to jump up. So some text below initialize, And if you bear with me for a minute, this is a slightly different keyboard than I generally code on. So all along, there'll be some minor fighting with things like exactly how do we navigate lines. But all of this is well and good for getting our log set up.
Thank Logitech.
So now that we have the log, the next thing we need to do is to actually turn our attention to the draw method. Down here in draw, we need to, if our log is enabled, draw it. Because once again, if we don't have the log enabled, there's no reason to bother going through all those lines and drawing them. Mm-hmm. So we'll do an if statement that says if log dot enabled. Then we will call log dot draw. Draw needs a sprite batch, which we can simply pass in the sprite batch held in this game instance. And then takes off our call to draw. Now, you'll notice that up to this point in the Drum Game project, we have not actually drawn anything. Mm-hmm. And we have not even gone so far as to set up our calls to spritebatch.begin and end. So we need to make sure we do that, since internally log is going to be using that sprite batch to draw things like the background rectangle and the actual text.
Okay.
So we'll make sure we get our calls to spritebatch.begin and spritebatch.end. Alright, that should take care of the draw method. Now we're ready to test.
I know this is probably a lousy question, but are you going to leave your braces in there even though you're only doing one command?
We will. Just looking...
You've been so good about it so far, Logan.
Just looking far into the future with some of the things that will need to happen with the way we'll be using different sprite batch blending modes.
The Magic 8-Ball told you it was a bad idea, huh?
Exactly.
Okay, no problem.
Alright. But with this, the log should actually be functional. So let's go back up to load content, and let's see if that's the case. Let's call upon our log. Let's tell it to write out a line of text. Let's write the word hello. Now, if all goes well and we have no major explosions, we should get the expected result of a line of text. And we get just that.
Woohoo!
So we have this nice dark-colored box to indicate where our log is, and we have a line of text appearing at the bottom of the screen.
It's working so far.
Alright, let's draw some more lines of text. Let's actually test that formatting routine that we so carefully put in.
Okay.
Let's call our second overload to WriteLine, and let's try some formatted text. We'll say that the screen resolution is, and let's give argument 0 by argument 1. And we'll finish off our format string. And then we'll specify in the current width and height of the screen. So looking back into the presentation parameters, we have back buffer width and presentation parameters dot back buffer height. So we'll run this, and we get the screen resolution is currently 800 by 600.
It's working well.
All right, let's do a test of the scrolling now.
By the way, I'm not going to tell Logan that generally I would consider that to be a very pretty font for a log. Don't tell him I said that.
Yes, planning is key. All right, moving on. We've got a few lines of text, but we're not actually pushing the limits of the log, so let's make a for loop.
Okay.
Simple for loop. Let's go maybe 6 iterations. And in those iterations, let's just keep logging out to WriteLine. So WriteLine, maybe we can go so far as to say what line we're on. We could say that we're on loop iteration number, whatever index 0 is. And then we'll specify I plus 1. So we'll have 1 based instead of 0 based. So now if we run, we see we have 6 things added to the log, and you'll notice this has bumped that original word hello off of the screen.
Yep, very cool.
So obviously if we add 1 more line of text, we bump everything off the screen, and away we go. But we can see that loop iteration 7 has appeared at the bottom. It is visible, and so the lines that we're losing are the oldest log statements.
Very nice.
Now, one last thing to prove is whether or not we can draw write to the log before the log is initialized. So to test that, we'll simply grab this for loop. Let's jump up to the very beginning here in the constructor and log some information here. Because obviously, in the constructor, we have not yet initialized the log, but let's test logging information nonetheless.
Okay.
Well, we can see that we had some iterations. Some of them have gone off screen. and we got hello and screen resolution after we did initialize. But you can see that as far as our use is concerned, it's completely transparent.
Right. It did all of the log iteration, or the loop iteration logging, all before we even fired up the log and still wrote it out.
And this means that throughout our code, we don't have to worry about, is this code getting called before load content? Is it getting called after load content? Mm-hmm. We can just call log.writeLine at will, and everything will work just fine. And I'm actually going to move this back here, which I believe is going to be kind of a moot point because this all gets erased in a minute anyway.
That's all right. All right, well, what's next?
One last thing we want to do is we already have the first place that we can apply the log. Mm-hmm. Back in our style class, matter of fact, if we switch over to style, we have this load texture method. And here in load texture, we're passed in some information, and we're expected to load and return a texture. Mm-hmm. But this method doesn't take into account is what would happen if we passed in some invalid name. Now, when we were coding the style class, we actually got to see what would happen if we did that. Before we expanded these paths, or rather combined these paths, we were passing a note directly without the style subfolder,
right,
and we got a nice explosion. The game crashed with an exception.
Right.
Now, if we would like a different way of the game to handle these errors other than the whole game crashing out, we could specify that with a try-catch block. So down here inside of our load texture method, more specifically with the return line, this is the line that's actually going to throw the exception, content.load. Mm-hmm. So what we'll do is we'll throw a try statement around this. And we'll say that...
Now, hang on, just real quick. You may be completely new to the concept of try-catch. It's really extremely simple. All it is just telling your program, hey, before you actually execute this, like, for real, I want you to try it in advance and make sure it works. Because if something goes wrong, I've got a contingency plan. If everything works fine, cool, then just continue. But if something blows up, then I have something very specific I want you to do if that doesn't work.
Exactly, because I'm sure if you've been programming for any length of time whatsoever in Visual Studio, you're familiar with the concept of exceptions.
Right.
These are generally what or how the program indicates to you that something has gone wrong. Outside of Visual Studio, these look like crashes.
Yeah.
Because you will, depending on a few different things, either get an error window telling you what kind of exception happened, or you may get something such as no information at all. The program may simply stop running.
Yeah. So really, this is just a really nice way of saying, I want you to try plan A, and if plan A doesn't work, then here's plan B.
Exactly. So here inside of load texture, we will try to load the texture passed in, but if we called load texture and we passed in gibberish for the name and that didn't resolve to an actual texture and cause the content manager to throw an exception, rather than have the game crash, we'll instead just log a message out to our log.
So this is the other side of a try. If you try something that doesn't work, the next part is a catch.
Exactly. So in this case, if any of the statements inside of the try block threw an exception, we will then land inside of the catch portion, and then we're able to handle the exception. So inside of catch, what we would like to do is write out to our log.writeLine, and let's put together some sort of error message. Let's say cannot load texture, and then let's give the texture's name. So we'll put some single quotes down, and then we'll say that, all right, parameter, or rather argument, index 0. So we cannot load whatever this texture is. And let's include the path that it was loaded from as well. So we can't load that texture from a value specified as a second index. And then we can finish off our format string. And then the first argument we'll pass in will be path.getFileName, or rather the path type.getFileName. And we'll pass in full name. Again, the whole point of using file name there is it's generally more important to see what didn't load, and then as a secondary piece of information where it was coming from. Mm-hmm. Full path is going to have everything. Also, the idea is that if your resolution is too low and your log font is too big, you have a crazy long path, like the path that the game is currently stored in, you may actually have your texture information drawn off screen.
Gotcha.
We'll flip that around. We'll draw the texture first, and then we'll draw the path. So we'll simply strip the path information off of the file name, and then we will include the path information by itself. that is path.get directory name of full path. So in both cases, we're looking at full path. We're just looking at different pieces of it. Now, if this was the case...
if you tried it and it worked, basically?
Yes, if you tried it and it worked. Or rather, if you tried it and it worked, the code execution is really simple.
Yeah, the catch would never happen.
You get into this, and not only that, we also return. So the moment this works, we return, and nothing else happens. So all the code down here doesn't ever get reached because we found the right texture, we returned it, everything worked.
Mm-hmm.
If we actually get down here, that means we never hit this return statement. And also, we run into a scenario where we have a code path where load texture is not actually returning something.
Okay.
Which presents a problem, one, for the compiler itself, but conceptually that's a problem because we're going to code the rest of the game to anticipate getting a texture back. The code is not going to handle getting null or nothing back from load texture. It is expecting a real, actual, usable, drawable texture from load. Now, in the case that we got this error message, writing the error message is all well and good, but we
still need something to work on.
Right, we still need something to prevent the game from crashing shortly hereafter when we don't have a texture. So a simple workaround here is just to return the current fill texture.
Which was just a color, wasn't it?
It was a single 1 pixel by 1 pixel texture that's color white.
Okay.
So that means if we see any tiny white dots appearing anywhere, then that's the visual indication that something happened. Though before that we should see the entries in the log. So basically we have this log to tell us what went wrong. We have this fill texture to make sure that any drawing routines, depending on the texture coming back, don't explode. And now we've just made our load texture method significantly more durable. Now to show this in action, just to give an example here, let's go back to game one last time.
I suppose in a pinch you could probably have like a default texture that actually existed in your content and then just call that if you couldn't find what you were looking for.
Oh sure, absolutely. You could make up a texture design that just says the word error in it, or load error.
Like I remember way back in the day, like in the Unreal Engine, they used to have that funny snot bubbly texture, and that was like their basic default, which was there really just as a reminder that you need to change something.
Exactly. So you could do the same thing here. You could make a default texture field, and the moment that load didn't work, you could return that default texture.
Okay, well I was just curious.
All right, let's put this to use. So let's actually use the style.load texture and then see what happens if we break it.
Okay.
So right here inside of load content, inside the game, let's make a local variable. Let's make this a texture 2D. Let's call it texture. And we'll initialize it by calling style.load texture. So this is actually the first test of some dynamic texture loading. Dynamic in the sense that we're handling this at an arbitrary time, as opposed to letting style handle it. All right, for the asset name, let's simply pass in note. And then to prove whether or not our texture loaded, let's draw the dimensions of that texture. And just to save on a little bit of time, I'm going to get exceedingly lazy. I'm going to copy this line where we were testing the screen resolution, simply formatting some arguments into the string, and paste that in right here. And simply say the texture resolution is, we'll feed in texture.width and texture.height.
Okay.
So since note is a real, actual texture asset that exists, this should run without issue. We can see that the texture resolution is 15 by 48.
Yeah, that works great.
Now, let's change this to a texture that doesn't exist.
Cat. Nice.
So we see that we don't have a cat texture asset. So if we try to load, instead we get cannot load texture cat from, and this is what I was talking about with the path. Given the current screen resolution, size of the font, and length of the path, we can't actually see the whole path.
But you could output this to a file.
That's true. We could start a logging session and accomplish it that way. But we can also see that we have a usable texture. It's just a 1 by 1 pixel texture.
Okay.
But I mean, that is indeed a valid texture, so we can go draw using that when that will cause no further problems.
Right.
So again, just proving that this is the intended functionality of load texture, and it is rather tolerant in that we can specify non-existent assets, and we get simple, convenient log messages as opposed to entire game crashes.
Cool.
Now, before we end out here, I do want to do some cleanup because we've got a lot of stuff we'd use for testing.
Yeah, a lot of stuff we don't need anymore.
All I'm going to do is pull out our test lines beginning with the hello text, our loop iterations, and our texture loading example. We'll pull all of that out, so we simply end off load content with our log.initialize call. One final build, make sure that everything gets saved, no further syntax errors, and so everything is working perfectly.
Very nice. So I guess with that, the log class itself is completely finished and implemented. And so we'll just move on from here. Thanks a lot.